Okay, dictionaries are one of the most powerful tools available in Python. Powerful because they're incredibly flexible. Dictionaries are non-sequential collections of key value pairs. And you can think of just a list, whereas a list is indexed by consecutive integers, 0, 1, 2, 3, 4. Dictionaries, in this sense, are like lists, but instead of being indexed by these consecutive integers, they're indexed by arbitrary Python types with a constraint that I'll mention in a second. So dictionaries are specified with curly brackets. They cannot be sliced like we've done with lists, like we've done with strings, because they're non-sequential. And the keys or indexes are arbitrary. So the value can be anything. So anything can be a value in a dictionary. But the key, which is our generalized idea of an index, must be immutable. So can a dictionary contain a dictionary? Yes, because a dictionary can have as any value, any Python type. So in this first example, is this a valid Python dictionary? So we have as our key, again, these are key value pairs. The key is a tuple, 1, 2, 3. Then the key value relationship is specified with this colon. And then the value is another tuple of strings A, B, and C. And this is a valid Python dictionary, as demonstrated by the output here. So is this a valid Python dictionary, where we have a list 1, 2, 3 as the key? Again, we use the colon to denote the key. Here's the key, and here's the value relationship, where again the value is the tuple ABC. Is this a valid Python dictionary? It's not, and that is because, as we set up here, the key must be immutable. So here we're using a list as a key, and lists are mutable. So that is why this is not a valid Python dictionary. Okay, like I said, we can think of the key as a generalized index, and given that we provide the key, we access individual elements, values in that dictionary, again using this square bracket notation. So here I've defined a dictionary which represents a complete blood count results. So I've got a white blood cell count. This is the key. The value is 5.9. A red blood count as a string is the key. The value is 5.23. Hemoglobin with a string is a key with a value 15.9. Hematocrit is a key with a value 45.5. And finally, lymphocytes is a key with a corresponding value of 32. So here I'm defining the dictionary. And then I can access individual elements of that dictionary with the square brackets and the particular key that I want to see. So here I'm going to print out a white blood count, hematocrit, and here I'm providing a key that doesn't exist in the dictionary as I've defined it. So let's see what happens when we do this. Okay, so we print out 5.9, 45.5, and then we get a key error. So it's telling us there's a key error. There's no key MCV in this dictionary. Well, alternative to the square bracket indexing, we can use an alternative approach, and that is to use the dictionary's get method. And this is a way that we can safely return values from a dictionary whether or not the key exists. And so the way it works is if you pass in a key, if that key is in the dictionary, then it returns the corresponding value. If that key is not in the dictionary, then it returns a default value. And that a specified value, and that is the default value is none. So here in this case, I'm using CBC get. I'm passing it this key which does not exist in the dictionary. And so it will return a value none, which is the default return argument for get. Here I'm doing the same thing, but instead of using the default none, I'm telling the get function, get method, that if there is not a key MCH in the dictionary, return the value -1. Okay, so dictionaries are these key value pairs that are integrally related. You can return the keys and the values of the dictionaries as separate lists with the keys method and the values method of the dictionary. You can return the key item pairs of the dictionary as a list of tuples. And so I'll demonstrate that here in each of these cases. So here I'm going to print the keys, here I'm going to print the values, here I'm going to print the items, which are the key value pairs as tuples, and here I'm just going to print the original dictionary. So first thing you notice as we defined it, the first thing we defined it was white blood count, then red blood cell, hemoglobin, and so on. But when we print the keys, it comes out as lymphocytes, hemoglobin, red blood count, white blood count, hematocrit. So this is an important thing, that the dictionaries do not retain order. So the order that you put something in is not preserved in the order that you get something out. And so the order that things come out will be arbitrary. Although, let's see, so here we have the, okay, so lymphocytes. Here are the items. See, here we have a list of these tuple pairs, and here we have a printout of the dictionary. You do notice that all of these do come out in the same order. So they're not the order that we entered them, but all these methods are returning the keys, values, and items and printing the dictionary in identical order. Okay, so that's a basic dictionary. There are some variations of this that are provided in the collections library of Python. So an important and useful one is the default dictionary. So the default dictionary provides a dictionary-like object, but with the caveat that it provides a default value for the key. So the behavior with indexing is identical to what we get with get. If we access the dictionary with a key that doesn't exist, the dictionary automatically provides the default value. And when you create the default dictionary, you have to have it provide what is going to be what type of default value is going to be associated with the dictionary. So in this case, I'm saying the default value in the dictionary is going to be an int. So here we create a dictionary, a default dictionary. There's nothing in it, and here I'm going to access the key, the value corresponding to the key A, and I'm going to add 1 to it. Of course, there isn't a key A yet in the dictionary, and so it'll take the default value. So let's see what our result is. Oops. Now let's see what the result is. The default value is 1, and so the default integer value that was provided was 0, and then we took 0 and we added 1 and assigned that to the key A. Okay, here we do the same thing, except for we are going to provide a default type of a list. So this will be an empty list. And so here we are going to provide the key names, and we're going to append Brian to it. So then when we examine that, now we have a list that has one element in it, Brian. Okay, so here we're going to take a default dictionary, and we're going to say the default value is a set. And I'm going to loop through this dictionary this list of tuples where we have a color and an integer pairing, and I'm going to add them to the dictionary, add them to the set. And when we print out the items, we see we have blue and red. So I'll have to okay, so do we have any so you see here we have a duplicate tuple. We have a red and 1, and here we have a red and 1. I have to think through this a little bit more. I apologize for being confused on this dictionary of how it is adding these values. But so that's default dictionary, something to explore, to be left to the student to prove that. Okay, and another variation of the dictionary that is provided in the collections library is an ordered dictionary. And that is a dictionary that behaves just like a regular dictionary, but it preserves its order. So the order that you add something in is going to be the order that you always get something out. So you might ask, why not always use ordered dictionaries or default dictionaries? And I believe the answer to that is that there is no free lunch. So whenever you take an object and you have an added functionality and added flexibility, usefulness to it, that comes at a cost. And I'm going to assume that that cost is a decreased computational efficiency when using these variations on a default in general use compared to a regular dictionary.